mentioned on the pod in the past that we're just going to see.
Trust it.
I think we're going to see a Cambrian explosion, no pun intended, of architectures coming out of China now that China has been effectively decoupled from the US tech stack. NeurIPS this year was a bonanza. I've called it in past Woodstock for AI. A few observations. It had more than 29,000 registrants this year, which is almost 50% increase over last year. It was enormous. The Alibaba, the Chinese lab, had 146 papers accepted, including Best Paper Award. Anecdotally, the language that I heard the most in the hallways was Mandarin. The frontier labs have all the resources. The academic labs do not. And the frontier labs were at NeurIPS mostly to recruit academics. American, again, this is sort of a sense of the conference, if you will. The frontier labs and the frontier research coming out of the labs has largely gone dark. So what was being shown on the research end was largely coming from academic resources or academically resourced labs that are lacking the resources. There was on the sidelines, even though frontier labs were there to recruit, the publications and the oral presentations at this point largely not coming from frontier labs, except for Chinese frontier labs, which is also...
So what is NeurIPS for, first of all? Let's start with that.
So NeurIPS, formerly NIPS, stands for Neural Information Processing Systems. Okay. So it is the largest AI conference in the world. It's held once per year, every December. And it is where some of the most striking AI research historically has been published. It's also the place, the one time per year where all of the frontier labs are all under one roof. And you get really a sense of the pulse of the AI space just from being there. Some of the most interesting meetings happen in the hallways. Optimus Gen 3, humanoid robots, there in force. You also see a sense of the vibes, the zeitgeist of AI right now. So you can see these are a bunch of photos and video I took from the conference. We've talked on the pod in past about how the Chan Zuckerberg initiative is now pivoted to solving all disease with AI, and that solve everything mentality, that math, science, engineering, medicine are just going to be solved imminently with AI, was very much on the show floor to the point where it made banners. It's really, I think, such a wonderful way to tap the zeitgeist of the space. There's a lot of hardware, and the feeling of the moment is that robotics in particular is the next big thing after agents. I should also mention a lot of the attendees watch and are fans of Moonshots. And I think there would probably be a lot of interest if we were to do a recording in the future from NeurIPS or ICML or ICLR.
Well,
it's a global thing.
I don't know what those TLA
all over
stands
the world.
I think we can't emphasize that dynamic enough. And Ahmad, I'd be curious to hear if you have a different take on this. But my take on the floor was that American frontier labs have basically gone dark and are largely no longer publishing all of their internal results. Chinese labs continuing to publish in the same way that they're continuing to push open weight models. And so that the gap, the research publication gap is being filled in part with Chinese labs. Strategically, it's great differentiation. If you have really strong American frontier models that are largely hidden behind APIs under the spirit of commodify or complement, release lots of open weight models. It's also, I think there's an integration angle. So if, again, under the banner of commodify or complement, a classic economic strategy, there is much more to AI than just the models. There's integration with society and the economy. So if there's strategically, if you're at a disadvantage on the model front, open weight, open release all of the models and focus your attention, focus your economy on deeply integrating all of those open weight models, and that becomes the competitive advantage. One of the many blockades to radical progress in terms of advancing AI models is obviously the context window size. It would be miraculous if we could have, say, 1 billion tokens in context or 1 trillion tokens in context. If we could have the entire web in context or the entire human genome in context, imagine the reasoning powers we'd gain and all of the problems that we could solve. The problem is, as folks in the space have long used to motivate just about every recent paper on the archive, the quadratic complexity associated with increasing the number of tokens in the context window. It's really painful to increase a conventional vanilla transformer past a few million tokens in context. So we resort to techniques like RAG, retrieval augmented generation, and other techniques to try to effectively increase the amount of working memory, if you will, that an AI model can keep. So Titans and Miras, these are Google's latest attempt to get past that bottleneck. And as we've talked about in the past on the pod, there are a variety of techniques, architectural techniques, to try to break the context window limit, like recurrent neural networks. Popular example, they don't have any explicit context window limitations, but they forget. So the approach that Titans and Miras propose is sort of biologically inspired, distinguishing between short-term memory and long-term memory. It's sort of ironic, given that the attention mechanism itself that's powering basically the whole economy at this point was originally designed for differentiable long-term memory. We found ourselves back there. The idea is to use surprise, a numerical metric of surprise, to decide what to commit to long-term memory and what not to. And turns out scales really well without catastrophic forgetting. Absolutely. And I think these papers and others, when Demis Hassabis talks about there being only 1 to 2 major AI advances at the level of transformers left before we achieve what he'd characterize as AGI, I think breaking the context window ceiling is probably at least half of one of those great advances. And I think we will absolutely get there pretty soon. Yeah,
Thoughts?
the catchphrase I heard over and over again at NeurIPS this week is that this is a rat race. There are so many employees at the Frontier Labs who are just grinding away, competing at what they view as a rat race to achieve the Frontier Max in this case. I fully expect, as I've mentioned on the pod in the past, that we're just going to see leapfrogging on a near weekly basis.
And we're
at
seeing
this
it.
point.
Absolutely.
Yeah.
Absolutely.
Until we get to the finish line. And I think the big question is, what does the finish line look like? I think
Well,
the closest analog I can think of is this is like a world war with multiple campaigns and multiple fronts and multiple thrusts and initiatives. Yeah, Vending Bench 2 and Vending Bench Arena, I love to the extent that we have any sort of economic Turing test or economic benchmark for agents' ability to autonomously deliver a return on capital. That is what we have right now. And as I've mentioned in the past, maybe just project this into the ether. I would love far better benchmarks for measuring economic autonomy than Vending Bench, but Vending Bench is what we have right now. I think if anything, XAI is relishing not being public given its history, but I think more broadly, the worst case economic scenario for superintelligence is that it, maybe not the worst, the next worst case is that it remains decoupled from the human economy and that an intelligence explosion happens not on the publicly traded markets, and that insiders and early employees and the machines themselves sort of skyrocket in terms of real wealth, but are largely decoupled from retail investors and the rest of the human economy. That would be, I think, a highly suboptimal economic outcome. Whereas if we get enough IPOs from Anthropic, from OpenAI, from SpaceX, from some of these other firms that are achieving hyperscale on land, in space, I think that is probably the best case from a macroeconomic perspective for the economy. And once those happen, assuming they happen, I think it's far clearer to see how the economy grows past the so-called debt crisis, how we achieve hypergrowth, real hypergrowth over the next 3 years. I think it's also worth mentioning the 50-year-old notion from economics of Goodhart's law, which is that when a measure becomes a target, it ceases to be a good measure. And the way that these models are trained certainly and superficially rewards various sorts of behaviors that might be construed as dishonesty. And being able to avoid Goodhart's law, clever ways to avoid Goodhart, I think are admirable on the part of OpenAI. And maybe the final solution looks a little bit less like naively optimizing just next token prediction objectives or reward maxing on RL objectives to solve math problems or programming problems. It looks a little bit more like some sort of multi-objective optimization problem where maybe there's some blend of a good heart avoiding honesty reward and an accuracy award and an ethics reward that maybe almost start to look a little bit like separation of powers in what we see in government systems. There's an executive, in some systems, a legislative, judiciary, etc. This is a template for how revenue is going to scale to justify the trillions of dollars of capex. It won't just be faster models or better models or stronger models. It's going to be lots of agents, fleets of agents, millions of agents, many millions, billions of agents, all running in parallel to solve problems. That is, in my mind, and certainly based on the architecture of Gemini 3 DeepThink, which isn't just a faster, better singular model, but it's also scaffolding to have fleets of agents, fleets of Gemini 3 agents that are all running in parallel to solve a given problem. That's the deep think part of Gemini. Parallel, yes, but quantum computing wishes that it had the economic utility of Gemini 3 deep think. Yeah, like when Dario speaks of countries of geniuses in a data center, this is what it looks like. We're going to have billions of agents that are all going to be independently probably pretty expensive, even though the cost of intelligence is going to zero. But collectively, yes, this is going to generate trillions of revenue if we have so many agents. And this is how we pay for all those data centers.
Well, Dave?
Yeah, this is sort of a finger in the eye to those armchair theorists who say that the small guys, the small labs, are going to benefit from algorithmic advances. This is a study that found that 91%, this is a study out of MIT, 91% of algorithmic efficiency gains between 2012 and 2023 were the result of only two things. One, the switch from LSTMs to transformers, and two, the switch from Kaplan scaling, named after my former office mate in the Harvard physics department, Jared Kaplan, at Anthropic, and the switch from Kaplan scaling to chinchilla scaling. Those two things. So LSTMs to transform, LSTMs were recurrent, transformers not.
What are
long short-term memory. So the LSTMs were, prior to the transformer revolution, LSTMs were the favored language model. I remember the old days prior to transformer, prior to GPT, when Andrei Karpathy had his char RNN language model that stunned people by being able to generate code. There was a life prior to GPT. But those two algorithmic transitions, LSTMs to transformers and Kaplan scaling to chinchilla scaling, those two were 91% of the efficiency gains. And what that says is that this story that, we're just stacking small wins on top of each other, and that eventually somehow algorithmic efficiency gains are going to enable smaller labs to have some sort of advantage relative to larger labs. This suggests that's just not true, and that most of the algorithmic efficiency gains are actually accruing to the large labs that are able to scale out the most. I think there's some YouTube viewers somewhere with a drinking game or a bingo game for how many times we can say tile the earth with compute or disassemble the moon or whatever it is. So drink your whatever or cross off your whatever on the bingo game to this one.
That's another one.
Robots are the part of the loop. I think this is, if I may, even more profound than just garden variety acceleration. If I ask all of you, or I request, don't think about pink elephants. Yeah. What's the first thing that happens? You start thinking about pink elephants, not in terms of text tokens in your mind. You're not probably thinking in terms of language. You're using your visual cortex probably to create a mental image of pink elephants. And the ability to visually reason is something we've talked about on the pod in the past. We're finally, a few weeks after this was predicted to happen, we're starting to see major gains in reasoning performance by models that can include visual tokens in their chain of thought, not just text tokens. And we're going to see a lot more of this. Imad has thrown some cycles at that previously. I know, Imad, I was catching up with some of your former colleagues from the MedArc days at NeurIPS. fMRI wants to be its own modality. Yeah, we don't have a slide for this, but I would definitely encourage the audience to read the national security strategy that was just released in the past 48 hours. It's most certainly eye-opening, and I think spells out a pathway for tech decoupling between the US AI tech stack and the Chinese tech stack. I'm reminded during the Cold War, the Soviet Union had what for those years would have amounted to an independent tech stack and was experimenting with all sorts of crazy architectures like ternary computing and other to Western eyes unconventional choices. I think we're going to see a Cambrian explosion, no pun intended, of architectures coming out of China now that China has been effectively decoupled from the US tech stack. And maybe many of those innovations will end up one way or another benefiting the overall world, benefiting the US tech stack. I think we'll see a lot more experimentation coming out of China post decoupling. I think we see an intelligence race, and that will lead to diversity. We're going to see so many different architectures that are all competing in the US. In the West, we have a whole handful at this point of frontier labs that are all vertically integrating with their own chip architectures, many of them in partnership with Broadcom or other lower level infra providers. Now we're starting to see the same happen in China. I think in the end, this heterogeneity that we're seeing in terms of tech stacks is only going to further accelerate the race that we're already in to the finish line. And I would pose the question, what is the finish line that we're racing toward? Because we're going to go much more quickly with this level of integration. I think all other things being equal, more experimentation can probably be better for humanity. Query whether it's good for the US or not. Query whether it's good for interoperability or not, but all other things being equal, more experimentation is probably better. I would just add, this to my eye looks like the beginning of universal basic equity. We've spoken on the pod about UBI, UBE, UBS. This looks like universal basic equity, where every person in the economy will have an equity stake in the economy. And if we do see hypergrowth, macro hypergrowth over the next few years, then $1,000 in a 530A account, which is, again, what this Invest America, thank you, Brad Gerstner, for helping to conceive this idea. What, $1,000 in an account now, in a 530A account, a few years from now, if we experience hypergrowth, could be quite material to a person's living circumstances.
Yeah.
I should also point out, Peter, I mean, just want to look at this for a minute from the perspective of economics. Right now, AI engineers are complementary good or complementary service to AI compute. The cost of intelligence is going to zero. And so right now, pursuing careers and majors in AI, highly complementary. Recursive self-improvement is also potentially imminent. And to the extent that recursive self-improvement gives us soon AI engineers, we might start to see AI itself become a substitute for AI engineering labor, in which case maybe this rush to major in AI at MIT and UCSD maybe reverse itself, unwind itself, and everyone goes back to majoring in the humanities like they used to. Agreed. I think that is the multi-trillion-dollar elephant in the room. As with college majors flocking to AI, in this case, right now, if you can pursue a career in the so-called skilled trades to facilitate tiling the earth with compute, drink your whatever again, I think that's potentially very promising local strategy. But of course, 5 to 10 years out, and I agree, Peter, with your timelines, we're going to see humanoid robot substitution effects.
All right, let's jump in. Yeah, go ahead.
What happens when we have last mile robotic delivery services?
Sure.
I think we have to prepare for that imminent future here, and that is probably best done by the private sector. Yeah, it's not a coincidence that there are 4 separate private space stations that are about to launch. These are actually all causally related to a NASA program. When we speak of privatizing the government, NASA in 2021 started the commercial LEO, low Earth orbit destinations program, with ultimately $1.5 billion in funding. And the SpaceX surge to space that we saw was in part the result of another analogous NASA program to try to commercialize space
the commercial
launch
crew
capabilities.
program. Yeah,
that's correct. That's right. So the commercial LEO destinations program was spun up in part because the International Space Station is going to need to be deorbited sometime soon. And there was a desire for a private U.S. space presence to succeed the ISS. So I'm very optimistic about all of these and other private space stations. I think we're going to see an exponential rise of humans in low Earth orbit sometime.
You know what
soon. Well, there has to be a vote, but the hearing was several days ago. I'm also, maybe to just comment quickly, I'm also not sure the historic story that Starlink would spin out and do its own IPO. I think with the rise of orbital data centers, I think that muddies the water somewhat in terms of Starlink as pure communication service versus Starlink as a predecessor to orbital data centers and putting compute up there and not comms capabilities. So in that sense, I think I could imagine a scenario where orbital data centers are actually pulling all of SpaceX to go public, not just spin off Starlink. This was basically the plot of season 3 of the television show For All Mankind.
I love that
It's a wonderful, wonderful show. The three-way race, in the case of season 3, it was a three-way race to Mars. In this case, it's a three-way race between SpaceX, Blue Origin, and China to land humans again on the surface of Mars by 2028 or earlier. And I think this resumption of a space race, which was dormant for 50 plus years and maybe also had collateral downsides for the rest of the economy in terms of overall innovation, it's coming back to life. We're back in the space race again, and one might hope we'll see a lot of growth and innovation come out of it. Yeah, I think this vertical integration by hyperscalers into space is probably an inevitability at this point. We're certainly not going to get our Dyson swarms. I also think, imagine near-term future. Are we going to get a Meta space station? Are we going to get an Anthropic space station? Maybe clusters in space for
fascinating.
I'll just comment, it could also be even cheaper than this once we get compact fusion online. A lot of these orbital compute projections are assuming that solar is the primary power source for orbital compute. It doesn't have to be. Once compact fusion is cheap enough, and there's no reason to expect it won't be, we can tile low Earth orbit at minimum with compute as well. And it won't require all of these expensive solar panels. One sentence. Salim wins. No, so I mean, solar in space is still fusion-based. It's just using the fusion reactor at the center of our solar system. So I think the question is, where do we want fusion power to be located for space-based compute? And as fusion reactors, and there have been a number of deep space probes that NASA and other organizations have launched that are using fission, for example, ion-based propulsion. It's not like nuclear energy is that foreign for space. Fission thermal has been used by deep space probes for decades. It's not like we don't know how to do it. What's going to be new is compact fusion. In particular, we've put fission-based energy in space for decades. It was going to have to be something. I mean, if you look at all the sci-fi plots, it was either going to be the discovery, again, For All Mankind, it was, without spoiling too much, it was either going to be ice on the moon or the discovery of microbial life on Mars or something like that had to motivate space exploration and development. Who knew that it was going to be data centers? Well, it had to be something.
It had to be. I remember when I was in college. I don't know.
Or maybe it'll accelerate it. I don't know. Peter, when you were founding SEDS, did you, I'm guessing, not foresee the plot twist that the killer app for space would actually be like getting enough compute available to do generative cat videos doing funny things? Yeah, so who knows what the asteroid belt will actually end up being used for. I think we're seeing a race to build Dyson swarms. It's as simple as that. It's not just a race to the moon. It's not just a race to tile the Earth. It is a race to put as much AI accelerated compute into low Earth orbit as possible. And Como Space emerged from nowhere. I had never heard of them several months ago. And I don't think an obscure or otherwise obscure Chinese provider is going to be the last story we hear for Chinese orbital AI compute. We're going to see probably a dozen different vendors from China. We'll see, as just discussed, a dozen hyperscalers in the West. And the concern maybe becomes like overpopulation on Mars, making sure that all of these Dyson swarms remain interoperable. The other comment, of course, is those models just want to learn. So for AI compute workloads, to the extent we're doing training or inference, they can be structured to be fault tolerant. I'll comment that the zeitgeist at NeurIPS this year was that humanoid robotics is the next big thing for AI after agents. I think this is how reindustrialization of the US and the West happens. I think this is probably the best path for radically increasing economic growth and automating the 2/3 of the services sector that relies on physical intervention. This is instrumentally convergent for the future that we want. I think they're both incredible. And I'd also throw out maybe a request to the audience for the show. If you're interested in supporting robot athletics in the United States, either as a host or as a vendor or in some other capacity, please reach out to me. I'd like to do what I can to ensure U.S. dominance and Western dominance in general with humanoid robots via robot athletics. Yeah, I think it's all of the above. It'll be warfare, it'll be in the kitchen, it'll be on the street, and you'll see, I think, governance and governments at different levels, whether it's municipal or national or international regulations for the parameters of what the rules of engagement are, making an omelet versus fighting a war.